Here are the notes on section 11.5. You can see the title is Circumferences and Areas of Circles. The circumference of a circle is just the distance around the outside. And the area of a circle is like the area we've been talking about in previous sections, just the amount of space that's inside of the circle. Before we get into this, let's talk about a special number, which is pi. And you've probably seen this symbol before and talked about it. That's the symbol for pi. It's actually spelled pi. And pi is defined as the ratio of the circumference of a circle divided by the diameter. Okay? So pi is equal to c over d. Pi is an irrational number. An irrational number means that it's a non-repeating and non-terminating decimal. So it never repeats itself in any sequential way, and it just never ends. It goes on and on forever. We use some approximations for pi. Pi is approximately equal to 3.14, or sometimes it's convenient to use a fractional approximation. The fractional approximation is pi is approximately equal to 22/7. Many times when you're doing problems in geometry, you're going to leave your answer with a pi in the answer. Occasionally we'll do a decimal form, and occasionally we will use the 22/7. There is a pi button on your calculator, and so let me just show you where that is. The pi button on our calculator is a second function button, so it's second, and then it's over here, the up caret, and that gives us pi, and if I press enter, then you can see this out to 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. So that's a very close approximation for pi. So when we want to do a decimal answer, we're going to use the pi button on our calculator, not just the 3.14. Okay, so let's get into a couple of formulas, the formula for circumference and the formula for area. And we're going to kind of think about these by looking at a series of circles. So I've drawn here on the screen 5 circles, and then I just couldn't draw any more with more sides, but we're going to talk about those. So the first circle has 4 sides, and the radius is r. You learned in an earlier section how to find both the perimeter and the area. So without getting into that, just the perimeter for that square inside the circle is 5.66 times the radius, and the area is 2.00 r squared. And so for the 6 side, here's the perimeter, and here's the area. For the 8 sides, here's the perimeter, and here's the area. For the 10 sides, the perimeter and the area. For the 18 sides, which was the biggest I could draw, perimeter and area. Okay? The 30 sides and the 100 sides are the next two, and I just couldn't physically draw those with the instrument that I had. But the perimeter comes out to be 6.27 r, and the area is 3.12 r squared. And if we could draw a 100-sided figure, we could use, as I said, methods from the previous section to figure out the perimeter is 6.28 r, and the area is 3.14 r squared. Okay? Well, let's think why the last numbers are significant. If pi is equal to 3.14, then that means that 2 pi is approximately equal to 6.28. Okay? So keep those two numbers in mind. 3.14 is approximately pi, 6.28 is approximately 2 pi. So down here, in the 100-sided figure, the perimeter is equal to 6.28 times r. So that means our formula for the perimeter, or we're calling it circumference, is equal to 6.28 is like 2 pi times r. Okay? Now remember that the 2 and the r here, if you take twice the radius, you get the diameter. So another formula for circumference is just pi times the diameter. Okay? So those are a couple of formulas that you can use to figure out the circumference of a circle. I'll put a box around those. Secondly, here, that the area is 3.14 times the radius squared. Well, 3.14 is a close approximation for pi, so therefore the area of the circle is equal to pi r squared. All right, so a box around that one also. Okay, so you need to remember those 2 formulas, or 3 formulas, as you're working on problems in this section. Okay, I think just to finish this up, I want to talk about a couple of circles. So I'm just going to draw a small circle. And we're going to say that this small circle has a radius of, let's say 3. And then I'll draw a bigger one, not necessarily drawn to scale, but just a larger circle here. Okay, and let's suppose that this circle has a radius of 9. Okay, so therefore the circumference of this circle, the smaller circle of the two, would be pi times the diameter, right? And the diameter would be 3 plus 3 is 6, so it's going to be 6 pi. Okay, the circumference over here for the circle with a radius of 9 is going to be pi times the diameter also, where the diameter would be 18, so this is 18 pi. So what I want you to notice here is I took the radius of 3 and tripled it to get a radius of 9. Well, the circumference, 6 pi, goes to 9 pi, so the circumferences are also tripled as well. Okay? So, but that's not the case when we talk about the area. The area of this first circle is pi times r squared, and so that's going to be pi times 3 squared, or in other words, 9 pi. Okay? The area of the second circle is also pi times r squared, which is pi times 9 squared, which is equal to 81 pi. Okay? So when I tripled the radius, went from 3 to 9, I actually multiplied the area by 9. Okay? So if you triple the radius, then you multiply the actual area by 9, and that's related to the idea that it's the radius squared. So the factor is by 3, but when you square that, you get a factor of 9. Okay, that concludes the notes here. You need to make sure you know the formulas for circumference and area, and we'll work on those problems tomorrow.